All right, good morning, everybody. Rub those Monday sleepies from your eyes. Get ready for something relatively new. This is Investigation 4. Today, we're all about the pattern recognition. Now, I'm going to do this very differently. I want you to take out your book, open it up to page 251. Hit pause on the video whenever I tell you. And when you complete each section, then I want you to call me over to check. There will be no Socrative quiz today. So let's start off right now. You should have your book out, your pencil out, and an answer sheet that's labeled Investigation 4. You should be opened up to page 251, and this is example 1. And it says, what rule seems to describe this sequence? And they want you to find the next two terms in the sequence. We've done this lots, right? Starting with 3, going to 6. Uh-oh, I don't think we're counting up on this sequence. Then we're going to 6, moving on to 12. Well, if I was counting by adding, 3 plus 3 is 6. But I'm not counting up by 6 because 6 plus 3 is not 12. That will not work. What am I really doing? 3 to 6. What else can do it? I might be multiplying by 2, right? 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. So 24 times 2 would have to be 48, right? Can you do this one in your head? 48 times 2, that would have to be 96. So what just happened here? Let me explain it to you. We actually have two types of sequence, and you're mainly used to this first one, a sequence that counts up, meaning adds, or counts down, subtracts. Those were called an arithmetic sequence. What we just witnessed was the other variety, a sequence that increases by multiplying by the same number, or if it decreases by dividing by the same number. Those are called geometric sequences. Think you got that down? It's listed in your book, and I gave you a few helpful hints here. So they're going to start asking you to decide whether the sequence is arithmetic or geometric, and then write the next 3 terms. I gave you a couple little helpful reminders. First thing you want to deal with and ask yourself, are the numbers getting smaller? Well, our operations that make numbers smaller is subtracting or dividing. Or if the numbers are getting larger, you automatically know that would have to be adding or multiplying. And just to refresh your memory, adding or subtracting are arithmetic sequences. Multiplying or dividing are geometric sequences. So let's take a look at what we got going on here. These numbers are definitely getting smaller. So I might be subtracting, or I might be dividing. Is there anything I can do to 55 to divide it to get a quotient of 51? No, I must be subtracting. 55 to 51, I bet you we're subtracting 4 there, right? And 51 to 47, we're going to go and subtract another 4. 47 to 43, are you seeing it now? We subtracted another 4. Are we ready? We are subtracting by 4 each time, just counting down by 4. We've done this loads of time, right? So we have 39 for that next term. We subtract another 4 and we end up with 35. We subtract the last 4 from it and we should have 31. Here's the part that's just a little bit different though. They want to say, is it arithmetic or is it geometric? So this, my friends, would be an arithmetic sequence, right? That's not too tough right there. Are we ready to move on and hit it again? Let's try this one. 3 to 9 to 27 to 81. Numbers are getting larger. I must be adding or I might be multiplying, right? Well, let's take a look one step at a time. 3 to 9, I might be adding 6. But if I added another 6 to this 9, would that be giving you 27? And if I added 6 more to 27, would that be giving us 81? No, I don't think I'm adding. Maybe I'm multiplying, right? 3 times what is going to give me 9? 3 times 3. So then 9 times 3 is going to give me 27. 27 times 3 is going to give me 81. Are you ready for the next ones? 81 times 3. I bet you can't do it in your head, but I know if you had a sheet of scratch paper, maybe your multiplication chart you're going to need, you'll find out that's 243. If I times that by 3, you might definitely have to stop for a scratch piece of paper. You'll find out that is 729. And then lastly, if I took that 729 and times that by 3, you should end up with 2,187, right? So that part wasn't so tough. Let's go on to the new terminology though. What was it? An arithmetic sequence or a geometric sequence? We were multiplying this time. So that would mean it is a geometric sequence. Okay, so that's a little bit brand new. Let's go and apply it to some story problems. Check this guy out. The stock market was rallying and Carole tripled her investments every week. Tripled. What are you doing if you are tripling? If she initially invested $2,000, how much money did she have at the end of 1 week? How much did she have at the end of 2 weeks? 3 weeks? And what kind of sequence are we making? So first thing I want to point out, because sometimes our math skills are better than our reading skills, we have 4 question marks here. So that means we're going to need 4 answers. She started off with $2,000 and we know she tripled her investment every week. What am I doing if I triple it? I think I am multiplying it by 3 if I triple something, right? So let's see, 2,000 times 3, hopefully we can do this in our head. That's going to give us $6,000 that she made in the first week. The stock market really must have been on a roll, right? And then it said it tripled again in week 2, 6,000 times 3, that would be 18,000, right? And then she tripled it again in the 3rd week. So I'm going to take this 18,000 that I just wrote down and I'm going to times that by 3. Can we do it mentally in our head? I don't know. What would be 10,000 times 3? That'd be 30,000. How about 8,000 times 3, that's 24,000. So 30,000 plus another 24,000, that could give us $54,000. Not a bad run on the stock market, right? Usually doesn't work out quite that way, but sometimes it does. Okay, $54,000. And now we have to say, what are we doing? Is it an arithmetic sequence or a geometric sequence? Well, we discovered multiplying by 3 is what we did to triple something. So that guy must be a geometric sequence. All right, are we ready for the next one? Here it says, Joey has $500 saved up for his first semester of college. He has to pay $25 a week to eat in the cafeteria. How much money does he have at the end of 1 week, 2 weeks, 3 weeks? And again, they want to know what kind of sequence we're making. Well, my first question is, if he's paying, is he adding money to this $500 or subtracting money from this $500 if he pays? Anybody here has always paid. You always have less money if you're paying, right? So he started off with $500 and he had to pay $25 at the end of the first week. He's down to $475. Week 2 rolls around. If he wants to eat, he has to pay. He now only has $450 to his name, and that's before he takes his girlfriend out for a date. After the end of week 3, he has to pay another $25, so he is down to $425 this time, right? And now again, they want to know, is this an arithmetic sequence or is it a geometric sequence? If I was subtracting each time, this guy sounds like he is an arithmetic sequence. All right, not too tough. So now I want you to stop and hit pause in the iPad. I want you to do problems 1 through 6 on page 251. Call me over to check it before you move on. All right, welcome back. Now we should have our book opened up to page 252, and I want to show you example 2. Here it says, in this sequence, the terms 4, 5, and 8 appear to be repeating. Do you see it? Here's 4, 5, 8. Here it is again. We are repeating these 3 terms. So what would be the next 3 terms if I'm just going 4, 5, 8, 4, 5, 8, 4, 5, that would have to be 8, and that would have to be 4 again, and this guy would have to be 5 again. Remember, terms are just the digits or symbols in a sequence, right? So now that we know that, let's take a look. Assuming the following sequence repeats after every 3 terms, they want you to write the next 3 terms. So let's see, here's 6, here's 4, and here's 11. Those are the 3 terms that are repeating. It's going 6, 4, 11, 6, 4, 11. So what's going on here? 6, 4, and then 11. And then this last guy over here, hey, that has to be 6, starting all over again. Terms are just the digits or symbols in the sequence. Check this guy out though. Assuming the following sequence repeats after every 4 terms, write the next 3 terms. So I'm going 6, 4, 11, 6. 6, 4, 11, 6. So what's going to be the next 3 terms? Well, I'll start with my first 6. I'll move into my 4. And then the last one I have room for is the 11, right? Not too tough if you break it down and read how many terms. So check out this guy. Assuming the following sequence repeats after every 4 terms, write the next 3 terms. So I'm using all 4 letters here, T-A-C-T. So the next thing, I don't want an A. I want to start back at the beginning with a T. Then I want an A. And then I want a capital C, right? So now I want you to stop again. I want you to do problems 7 through 10 on page 252 of Investigation 4. And I want you to call me over to check those before you move on. Hey, welcome back. If you made it this far, you're not doing too bad. Let's take a look at page 253 on example 3. Here it says, what pattern does this sequence appear to follow? This is kind of weird. Here's 1 and a 0 and a 1. Only now I have 2 zeros and then a 1. And now here I have 3 zeros and then a 1. Are you sensing a pattern? Next thing up, I'd have 4 zeros, wouldn't I? 1, 2, 3, and then finally the last little 4th one. Then I'd have another 1, wouldn't I? So I go and tell my students that you always got to think on these. And the book is saying to describe a few. I actually, when it says a few, I want you to list the next 3. The toughest part here is you are going to have to write some sentences because you have to describe the pattern. And it's going to be very subjective. What one person says is the pattern might be written completely different from what the other guy says. Don't worry about that. We are so used in math that there's only one right answer, right? This is more like reading comprehension. There can be many, many, many correct answers. So check out this. Here it says, describe the pattern the sequence appears to follow, then write the next few, which we said is going to mean 3 terms. These are thinkers. What's going on? Here I have 4, 5. Then I have 4, 5 again, and now I have 6. Then I got 4, 5, 6 again, only now I have 7. Do you see it? 4, 5. Then I have 4, 5, 6. And lastly, I'm going to go and have 4, 5, 6, 7. So where are we starting here? We're back to 4. This guy's going to be 5. This guy's going to be 6. That guy would have been 7. The next one would have been 8, right? But how to describe this? There's going to be many, many, many different ways you could. I'm going to say it this way. I'm going to count up by 1 for 2 terms. Then count up by 1 starting on the same number for 3 terms. Then start with 4 again and count up by 1 for 4 terms. So let's go and review. Count up by 1 for 2 terms. Did that. Then count up by 1 starting on the same number for 3 terms. Did that. Then start with 4 again and count up by 1 for 4 terms. That sounds like it would work. Again, don't get hung up on this writing part. It's going to be very, very subjective. What is going on here? These aren't numbers, Mr. Hines. These are shapes. And it's saying, describe the pattern the sequence appears to follow. And again, write the next few, which we're saying is 3 terms. So it looks like I got an L, and then I got this guy, and then I got this guy, and I got this guy. Do you see it? Because here's the deal. They're all the same shape. First he's being tilted this way, then he's being tilted this way, then he's being tilted this way. So what's going to be the next one? I bet you that would be back to being a capital L again. So the next one would be sideways, and then I'd have this guy, which would be the capital L upside down. So the trickiest part is actually describing it. What would you call this? I'm rotating them. And each time, how much am I rotating them? Can you figure that out? If you go all the way around like you're on a bike or a skateboard, that's called a 360, right? And here's the deal. We kind of talked about right angles because they said a right angle was 90 degrees. Well, if you think about that, 360 divided by 4, that is 90, isn't it? 90 degrees is 1/4 of 360 degrees. So I would probably end up going and describing this guy. I'll say you rotate the letter 90 degrees. And last little bit, if I'm spinning it this way, that's the same way a clock moves, isn't it? So I'm going to call it 90 degrees clockwise. Check out this one. Describe the pattern the sequence appears to follow. Then write the next few. We're saying 3 terms. Hey, this isn't your regular alphabet. This is the regular alphabet. Now I know my ABCs, right? So what's going on here? I have A, then I have B, but I don't have C, then I have D. And then I have E, but I don't have F, and I have G. And then I have H. Can you see the pattern? So A, B, but I'm skipping over C, right? C should have been right there. Then I have D, E, but I'm skipping over F. F should have been right there. Then I have GH, but I don't have I. I would have been the one I left out. So what's going to be my next 2 terms? J and K. So I'd write capital J. I'm going to write capital K. But I don't want this L, do I? I want an M. Are you ready to think? Because that guy is definitely a thinker. And how are we going to describe it? So we could say, start with 2 letters in the alphabet. Skip the next letter. Continue with the next 2 letters. Again, it doesn't have to be written exactly that way. You just have to write your thoughts neat enough so I can read them and that you can go and tell that you understand what's going on. Math is not always just about numbers. It's about being able to convey what the numbers or what the patterns is doing. So now I want you to stop again. Do problems 11 through 15 on page 253 of Investigation 4 and call me over to check before we move on. All right, if you are back, we are now on page 253. Let's take a look at example 4. What are the next 3 terms in this sequence? Here I have 0 and I have 1, 3, 6, 10. And remember this bit I was telling you. If the numbers are getting smaller, that meant we're subtracting or dividing. If the numbers are getting larger, that meant we were adding or multiplying. Now that part still stands true. I have to be adding or I have to be multiplying because the numbers are getting larger. But what am I adding by? Do you know? Take a look. I'm not adding by the same number each time. 0 plus 1 is 1, but 1 plus 2 is 3. 3 plus 3 gives me 6, and 6 plus 4 gives me 10. So let's follow this pattern now. I'm just adding by 1, then adding by 2, and so on. So I'm going to be adding by 5. 10 plus 5, welcome back to second grade. That's got to be 15. If I added by 5, now I better add by 6. 15 plus 6, that's going to be 21. And if I added by 6 for this one, I'm going to have to go and add by 7. 21 plus 7 sounds like 28 to me, right? That's not too tough. If you go and write on top of them, that will always help you see the sequence. So check out this guy again. What are the next 3 terms in this sequence? 3, 4, 7, 12. I started with 3. I added 1 to make 4. Then I added 3 more to get 7. I added 5 more to get 12. Add 1, add 3, add 5, add 7, because I'm going up by the odd digits, aren't I? So 12 plus 7, hey, that's 19. Now if I added 7 there this time, I want to go and add by 9 would be my next odd digit, right? 19 plus 9, that's going to give me 28. And if I'm adding by my odd digits, now this time I'm going to go and be adding by 11, right? 28 plus 11 more, yeah, that's got to give me 39. That's not too tough. If you break it down, feel free to set them up and write them out. If you write up the numbers, the pattern is going to become very apparent to you. So now I want you to stop. I want you to do problems 16, 17, and 18 on page 254. Call me over just to check these 3 before you move on. All right, welcome back. We're almost in the home stretch here. Couple little things left, but we've seen this before. We didn't know what the name was. We have studied patterns in sequences. There's also patterns between pairs of numbers. And remember, a pair just means 2. A function table shows the relationship or function, these 2 words are synonyms, between related pairs of numbers. Do you remember these guys from about the first 15 lessons or so? I'm thinking you do, and we always said it's all about the arrows, right? If you're starting with 1 and going to 4, or starting with 4 and going to 8. The secret was figuring out the arrows. This is showing the function or relationship between these two numbers. This is the same view, only this guy goes a different direction. It's the exact same data set up on either a horizontal or a vertical function table. So what is the relationship that they are trying to show? If I'm starting with 1 and I'm getting 4, or starting with 2 and ending up with 8, or starting with 5 and ending up with 20. On each one of these guys, I am multiplying by 4. 1 times 4, hey, that's 4. Check it out down here. 3 times 4, that's 12. This guy down here, 5 times 4, gotta be 20. And again, the guy on the bottom, same thing, just horizontal or vertical, right? So now that we know how to read these again, let's take a look. 8 gallons is how many quarts? Well, I'm starting with 8. We just said the function was to multiply by 4. So 8 times 4, yeah, that's 32 quarts. Once you see the relationship or function between the two numbers, it's pretty easy. So check out this one. Refer to this function table to answer these next two problems. In and out. I'm going in with 10, I'm coming out with 2. Sounds like a casino. I'm going in with 15, I'm going out with 3. I'm going in with 20, I'm going out with 4. So on and so on and so on, right? So let's take a look. What does the function do to each in number? What am I doing? Am I multiplying by 2? 10 times 2? It's not 2. Does it subtract by 8? Well, 10 minus 8 is 2. Don't get excited yet, though. Check it out. 15 minus 8, is that 3? Or 20 minus 8, is that 4? No, if I read all the way down my function table, it doesn't always subtract by 8. Does it multiply by 5? 10 times 5? Nope. Here it is, the last one. It's dividing by 5, right? 10 divided by 5 is 2. 25 divided by 5 is 5. One more of these. It's saying, look at this again. We figured out that the function was divide by 5, right? We just learned that on the other page. So if 55 is used as the in number, and I'm dividing by 5 for the function, what's the out number? Hey, that'd be 11, right? One more, we're going to look at a different function table. Hours worked compared to dollars paid. That's the way it is in the world, right? I'm starting with 3 hours and I get $18. 6 hours worth of work gets a guy $36. 8 hours worth of work gets a guy $48. And 11 hours of work is worth $66. What is the function of this table this time? Looks to me like I am multiplying by $6 each time, right? 3 times 6 is 18. 6 times 6, hey, that is 36. 11 times 6, that is 66. So, describe how to find dollars paid if you know the number of hours worked. What do you have to do? You would have to multiply the hours by $6, wouldn't you? That's what you have to figure out. One more here. Here it says we're using the same old function. It says If the table above shows DeMarcus's pay rate, how much money would he earn if he worked 25 hours? Well, we just got done here saying you'd have to multiply the hours by $6, right? So let's go ahead and do this. 25 hours times $6. 5 times 6 is 30. I'm going to write down my 0. I'm going to carry my 3 over here. 6 times 2 is 12 plus 3 more. So DeMarcus would take home $150 in his paycheck, but that's before they take out taxes. It would actually be close to about $120. Check out this one. Number of days and miles walked, right? And it tells you Elmira walks 5 miles a day. The table above shows how many miles she would walk in a given number of days. They just want you to copy the table on your paper, fill in the missing numbers, but check out this part. Then use the calculator on your iPad to predict how many miles she would walk in a common year. Hopefully you know how many days there are in a common year. Otherwise, you better look that up. So, this problem would have 2 answers, right? Just wanted to make sure you knew how to do the last section because now we're going to finish it up. Finish the rest of the investigation. Call me over to check it out before you hand it in.